Okay, so now that we have gone through the syllabus already, so let's now talk about something more relevant about the subjects for this course. We only got about 20 minutes today. We'll do as much as we can. Okay. First of all, let's just start with about a course learning outcome. All right. Let's read it together very quickly. Okay. So here the first one, we want to instantiate a range of standard abstract data types. That's something we will have to study about what abstract data types really is. Okay. Some example would be, for example, there's something we're going to learn: stack, also queue, and also tree, and also something called priority queue. All right, so these are just some examples that we're going to go over. Okay, and when we actually learn about ADT, you definitely have to be clear about what's the expected operation you have on the ADT. Okay, and then you have to implement those data structure. Especially, we're going to implement the trees. That's really the focus for this particular course. Okay, when you get to maybe 3101, maybe with me again, we're going to look at how to implement graphs. Okay, but for this course, only the trees. Okay, and then we're going to apply software engineering principles. Okay, specifically, we're going to look at how we can do JUnit testing. Especially, it's something to do with regression testing. Regression testing simply means you are given a set of test cases for your projects, right? So those test cases define about the correctness of your project. If you can pass everything that you're given, that means your software is somehow correct with respect to the test cases, right? So that's it. You have to make sure any changes you make to your software projects, you have to always rerun the same test cases to make sure everything is passed. If something fell, there's something wrong. You got to fix it, right? Regression testing. And then we got to look at to reason about data structures. Okay, so reason about. Okay, that's something we'll see. Contract assertion invariant, that's something we'll get to. For now, you don't need to worry too much. Okay, asymptotic running time. Okay, it's something called big O notation. Maybe in your 1019, maybe your previous math course, you maybe learn about this mathematical concept over here. But in this course, we're going to see how we can apply the definition of big O, which we're going to review and also reintroduce. How we can apply that to software development, coding. Given a piece of Java code, figure out its running time. Okay, that's something we'll do a lot. And then you have to select the most appropriate data structures over here, right? So for you as a scientist or software engineer, when you are solving a problem, you might have multiple solutions possible. You got to choose the one that's the most efficient in terms of the running times. Okay? So the fundamental decision, one of them is about whether you should really use an array or linked list. This will be some very important question to really answer. So once we actually cover, so we're going to cover recursion first for this course, just maybe 1 or 2 lectures. And then we're going to do big O to make sure you're comfortable with the notation. And then we're going to talk about linked list all the way to about a reading week. Okay, so that's really something I will emphasize a lot. Okay, so course learning outcome, keep that in mind. That's something we'll definitely do. But of course, there's not much details over here. That's intentional, right? Just about big picture. Okay. And then, okay, before I get to the searching problem there, let's go over a little bit slides right here. Okay. All right, so just set the big picture. Software engineer, since you are in the software engineering program, or maybe just engineering in general. Okay, you will typically be given an API. Okay, so you will be given basically JUnit test cases, and from the JUnit test cases, you're going to figure out about the methods you have to define in a new class. That's something you will see right away, maybe from assignment number 1. Okay, that's something you will see. Okay, the API. And then regression testing. So you got to make sure all the test cases should always pass automatically. Okay. And then you want to also think abstractly. So when I say think abstractly, that simply means for you guys, think abstractly. You don't necessarily have to connect your Java code to maybe some hardware device. You don't have to. Just based on whatever that's really working on the Eclipse, you should be able to figure out whether your software code is actually correct. What will be the best way to do it? Of course, you can start by inspecting your code manually using your eyes and just do some paper and pen analysis. But the best way to go forward will be using debugger. That's something I will also show to you briefly, either Thursday or maybe next Tuesday. So here you learn about, okay, so for those of you who are in software engineering program, okay, in 2101, you learn about concrete data structure, like stacks, queues, also arrays, etc. But in 3342, 4315, like a later course you're going to take, a software engineering degree, you can learn about abstract state machine. They're somehow related, right? I wouldn't say too much about how they are related, but you can keep that in mind, in perspective. All right, very relevant fact is, let's say if you do any programming interview, you're not necessarily required to write some programs in IDE. You might be asked to use some whiteboard, maybe blackboard, to really do some programming. Right? So there might be some exercise you want to try as well. That's basically what I will normally do when I explain the exercise and walk through the problem with you. Okay? That's something you want to look at too. All right, so for those of you who may want to be licensed as a professional engineer, maybe after your graduation, maybe your job will require that. For example, you work in maybe Ontario Power Generations. They might require you to be licensed, right? For those, just give you one slide, just very quick context. There's something called Code of Ethics. What will be the expectation on you as a professional engineer, right? There are many aspects, but I want to mention just two of them, okay? There are fairness and also high ideal, etc. But number 4 and number 5, about knowledge and also competence. For this course, knowledge will be about the various data structures. You're going to know how to implement them and also about their analysis. Competence, you should be able to put things into practice, working, like a Java code, right? So these are the two. And in real life, let's say you are hired by some construction company as a professional engineer, and then somehow the bridge you're building is now, you believe is fit for use. What you do is you have to put your personal stamp on the documents to say it's certified to use. What if the bridge collapses later? Right? You're going to think about the kind of consequence, right? So that's why when you actually do your engineering work, it has to be based on very solid foundation. If you're lucky, you might just be suspended or terminated with your license. Or you may want to go to jail, right? Lawsuit, right? So that's a slide here just to show you the perspective for those of you who may want to become a professional engineer. That's really what the degree is preparing you for. All right, those of you who might be interested, I think for Ontario, they have a PEO, Professional Engineers Ontario. They have the Code of Ethics and also different resources. You can take a look, okay? But if you may relocate yourself to other part of Canada, they're all relevant, right? If you go to elsewhere, they also got similar association, okay? Just for your information. Okay, this course, okay, quickly. We're gonna talk about data structure. I'm gonna maybe summarize about all different terms, but just go a little bit, okay, just overall. What's really data structure? Data structure is just about how you organize the data. When you organize the data using maybe an array with indices, or you might want to organize your data using linked list with some references like aliasing, which you learned from 2030. Or you may want to organize your data using trees, which is even more general way to really organizing the data, right? So different ways. Each data structure we learn is a particular way to really access the data, okay? Just different. And also we're gonna learn about, for this course over here, we're gonna learn about array, linked list, stacks, queues, not really maps, but trees for sure. Graphs will be for 3101, okay? Algorithm. we wouldn't emphasize too much about exactly the algorithm, like a greedy algorithm or dynamic programming. That's going to be in 3101. But algorithm, don't think that's too complicated. Basically, anytime if you're defining a method which got step-by-step instruction, it's really an algorithm, right? It's just a way to tell the computer what to do step by step. Okay, and we're going to see inserting, deleting, sorting. Okay, and for sorting, let's talk about it. Okay, so this is something I would like to mention right in the beginning. Okay, to me, I think a software engineering or computer science undergrad, when you graduate, there are at least certain sorting algorithms you should know. You know sorting, right? Let's say you give it an array in no order. You want to sort it from smallest to largest. Okay. What kind of sorting algorithm do I think you should know? Okay, I'll list them. Okay, right here. So sorting. It's so-called a sorting problem. Just before I start, what kind of sorting algorithm do you guys hear about or know about? Quick sort, that's good. We're going to cover that in this course. Bubble sort, and that's also a very good sort. And for that one there, we wouldn't cover that in this course, but just for you guys to watch it for fun, right? There's a very famous YouTube, very famous YouTube video. If you search for Obama bubble sort, you'll see what I mean. Okay, hopefully the video is still there. Okay, yeah, yeah. Merge sort, yes, we're also going to cover that. Anything else?
There's a really bad one, BOGO sort. It's BOGO.
BOGO sort.
Really random.
Maybe mention that to me after class. I'll be interested. Okay.
You keep randomizing the array until it eventually becomes sorted.
This is sound very efficient. Yeah. Good. Good. So quick sort, merge sort. Anything else? One more call. Then I'll mention the complete list.
Insertion sort.
I like it. Insertion sort and also selection sort. They're similar. Okay. And there's another sort, heap sort, which we're going to learn. All right. Okay. I'll list them. Okay. It's a good way to really kind of put you in perspective. Okay. So number one, we got insertion sort, selection sort. Insertion sort, selection sort. These two sorts, we'll encounter them first, maybe in about the second or third week. So these two sorting algorithms are iterative, meaning that you are simply just going to write loops to really achieve the sorting, okay? Especially nested loop. We're going to use these two sorting algorithms to really use as a case study for analyzing running time, okay? And number two, it will be merge sort and quick sort, okay? So these are the recursive algorithms. So we got merge, sort, and also quick sort. So these two are kind of interesting. First of all, just to start with, they are recursive. And we are only going to talk about these two recursive algorithms when we talk about part 2 of the recursion, which means it's going to happen maybe after reading week. Okay? I want you to make sure you're solid for part 1 before we talk about merge sort and quick sort. Okay? And also, in order to analyze their running time, we have to learn about something called recurrence relation. Okay? You don't need to worry about what that exactly really means. Just keep in mind there's such a term called recurrence relation. Whenever you design some recursive algorithm using recursion, to really see how efficient it is, you have to somehow, first of all, formulate recurrence relation for the algorithm and solve it on the paper. Okay? That's something we'll do as well on the, in the lecture. All right, number 3, which is my favorite. Okay? It's called heap sort. And by the way, the heap over here is not referring to the static memory, like what you learned in 2031. There's also a term called heap, like a memory portion. Not exactly, right? The heap over here, okay, I can just mention a little bit, okay? The heap sort here is, to me, it's a very interesting algorithm. The sorting algorithm itself is actually very simple. just about adding something and deleting something, very simple. However, in order to really define a heap sort properly, you have to define what a heap is. What's really a heap? Basically, a heap is really a particular kind of tree. And the tree has to satisfy certain structural and also relational property. Don't worry about it, I just want to mention that. So the heap itself is going to take us about almost 4 weeks to really gradually build it up. First of all, you're going to understand what a tree is. Number 2, understand what a binary tree is. Number 3, what a balanced binary tree is. Number 4, what a search tree is. Number 5, how you can build a heap, right? There are many things you have to understand first before you can understand what a heap is. And once you understand what a heap is, the heap sort itself, a few lines of code. That's it. Okay? That's something we'll do later. Okay, okay, that's about sorting. And then analysis. Okay, about the correctness over here, we wouldn't do too many correctness proof in this course, but I do have at least one example about how you can prove some mathematical property about trees using mathematical induction. It's actually some very important concept for you to know as well. We'll definitely emphasize more about mathematical induction in 3101, but in 2101, I think you should also get some exposure to it. We'll get there, once we get there, when we talk about trees. But it's mainly going to be about analysis for the efficiency, which is an asymptotic upper bound. Okay. All right, let's now talk about some very quick motivating problem. I can present a problem. We can have some preliminary discussion. We'll continue with that on Thursday. 4 minutes, okay, and then we're done for today. So here's a problem. So let's say we have a mega city that has more than 10 million residents, maybe Shanghai, London, New York, etc., right? The problem is, let's say we store all the residents' data in a single array, okay? And then, let's say given a particular resident's social insurance number, ID, the SIM card, it can uniquely identify where a particular resident's record is, right? Uniquely identified, that's a keyword. So now the thing is array the fastest way to do? Right? That's a problem. Okay? Look at the problem description one more time, okay, more carefully, and then I want to present to you some potential solution, have some little discussion about it, and then we'll continue on Thursday. Okay? I think that's a good break point. There we go. All right, let's take a look. This is some sketch code just to see the idea. So let's say we got some resident record. Okay, so when we return this particular object reference, we have an algorithm, like a method called find. And then we have the SIM card right here. So the SIM card number here is unique. Uniquely identify a citizen. All right, so let's visualize what's happening here. Since we say 10 million, right, let's stick to it. So let's say we have some database. It's basically a single array. I'm pretty sure you guys have seen that many times. So since we got up to 10 million, so index 0 to all the way to 10 million, which is 10 to the 7 minus 1. Agree? Okay? From smallest index to the largest index. And then, for each record in the array, if that's not null, could be index I, for example. And then from here, we have some resident record, right? You can think about this is an object of type resident record. And one of the attributes there is a SIM card number. So this will be the SIN. So this will be some integer for us to check. Right? That's a problem. Okay? So now the question is, we want to get some intuition about how efficient or how inefficient using array is. Okay? So now, let's say this. In order for me to find out this particular SIM card, let's say maybe it's here, right? Or maybe around the end or in the beginning. I'm going to run a loop, go over potentially the entire array. And then as soon as I find that the current I, the SIM card is matching the SIM I'm given as the input. That way, I know I've found it. I can return. So now the question is, usually when you analyze for running time, you think about the worst case. You don't think about best case. Best case could be, maybe I have found it right away. It's not very meaningful. You want to more think about what's the worst case. Whenever you want to compare performances among different alternative solutions, always think about the worst case. In this case, what will be the worst case? 30 seconds, and then we're done. Think about worst case in terms of how many iterations maximum you may have to run. Go ahead.
It's the last one, so it might be the last one.
Might be the last one, yeah. So somehow worst case could be either the very last one or even the second last one, right? Which means you're very close to the end when you have found it, right? Okay. So guys, I think that's good enough intuition just for today. Okay, we'll start from next Thursday. Please make sure read everything about syllabus and open letter. We'll start from scratch. Thank you.